a vertical flip, and a horizontal flip. Now, when I'm talking about a vertical flip and a horizontal flip, imagine we had our graph. A vertical flip would hold the x-axis still and spin it. So just like a pinwheel. The stuff from the bottom ends up on the top. The stuff from the top ends up on the bottom. In other words, we change our y value to its opposite. Negative y's move up to positive. Positive y's move down to negative. So a vertical flip is when we take don't write down what I just wrote. It's the opposite of what the correct answer is. A vertical flip, we're going to take the y values and make them their opposites. So whatever we have for the function, the output, we take the opposite. It's a negative outside of the function. A horizontal flip would treat the y-axis as the thing that doesn't move, and the pinwheel effect would happen. The pinwheel effect would happen left to right, horizontally, flipping things that are on the left to the right, flipping things that are on the right to the left. So we're taking our x value and taking its opposite. A horizontal flip is taking the opposite of the x. So just like vertical stretching and vertical shrinking is referred to as horizontal shrinking and horizontal stretching, depending on whether we are multiplying by the whole function or just multiplying by the x. Vertical things are up, down, adding, subtracting, multiplying by the whole function. Horizontal things are left, right, adding, subtracting, multiplying by just the x. Same here. Vertical flip, where the x-axis is the point of revolution. Since it's flipping everything vertically, that's up, down. That is the opposite of the whole function, a negative with the whole function. Horizontal, left, right, that's taking the opposite of just the x itself. Horizontal is x stuff, vertical, y stuff. So if we had, I'm just going to draw 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's all we're going to need on left and right. Okay, so from -3 to +3, I have points on the y at +3, +3, +1, +2, 0, -1, +1. So that's each of those 7 points, -3, -2, -1, 0, 1, 2, 3. It's at +3, +3, +1, +2, 0, -1, +1. This is f of x. I would like us to draw negative f of x. And actually, I'll bust out another color here. Negative f of x is going to be in green. So we're going to take the opposite of the f of x, the opposite of the y value. Instead of 3, it'll be at -3. Instead of 3, it'll be at -3. Instead of 1, it'll be at -1. Instead of 2, it'll be at -2. Instead of 0, it'll be at 0. Instead of -1, it'll be at +1. Instead of +1, it'll be at -1. I literally just took the opposite of each of my y's, each of my f of x's, and made that the new point. And now, what do I have? So it's not wanting to be very agreeable in terms of seeing everything. There we go. It's a vertical flip. I'm not going to do it, but if I swapped all the x's for the x, you know what? I'm going to do it. I'm going to do it in red. I'm going to attempt to make the red show. There was a reason I was just using black and blue today. F of x, sorry, red's going to be f of, you know what? I have enough colors left that I could use black. In black, f of -x. This should be a horizontal flip. We're going to take every x value and replace it with its opposite. So I'm doing it from the blue. Instead of an x of -3, this one would go to an x of +3. So the y is staying the same. Instead of this being at -2, it's going to be at +2. But the x is changing. Here, the y stays the same, but instead of -1, it's +1. Here, the y stays the same, but for x, instead of 0, it's 0. Because that's our point of revolution. Here, instead of 1, it's at -1. Here, instead of 2, it's at -2. I'm glad I did it. This is hard this way. Here, instead of 1, or sorry, instead of 3, it's at -3. It's the blue one revolved around the x-axis. So again, vertical flip, the opposite of the whole function. You take your opposite of your y's. Here, horizontal flip, you take the opposite of your x's. this one, the opposite of the square root of the opposite of x plus 2. What order do we do things in if we wanted to graph this? Obviously, we're starting with f of x equals the square root of x. So our starting position is the square root of x graph. It does turn out that just like we have an order of operations, we have an order of transformations. And if we don't follow it, we don't get the right final graph. And we're going to talk about the order of transformations. First, we're always going to take care of our horizontal shift. That's our left-right movements. Second, any horizontal or vertical stretch or shrink. First, horizontal shift. Second, horizontal or vertical stretch or shrink. Third, our reflections. And those would be across the x-axis or across the y-axis. Over the axes, A-X-E-S is the plural of axis, A-X-I-S. And then finally, the vertical shift. Our up, down. So the order of transformations, which you probably didn't even realize was a thing, I, being the teacher, totally knew it was a thing. You'll never know. I did. The order of transformations. Horizontal shift, left, right. Our horizontal or vertical stretching or shrinking. Remember, a horizontal stretch is a vertical shrink. A vertical stretch is a horizontal shrink. So that's why it's all in the same step. They're really the same thing. Third, our reflections. Flip over the x-axis, flip over the y-axis, do both, whatever it's telling you to do. And then finally, the moving up, down. So here, negative square root of the opposite of x plus 2. What our first transformation should be would be the horizontal shift. And here, that's whatever we're adding or subtracting to the x. Plus 2 with the x, remember, is the opposite of what you'd think it is. Plus on a number line with the x would normally mean right. I'm going to my right, but you're seeing me go to your left, so this is confusing. Let me not do anything with the camera. Let me just use my hands and keep them below, because as we figured out before, if I move my hands to the right on the board, they go to the left up here. So I'm going to keep them below. Here we go. Normally, when we add or subtract to the x, we can think of it as being the opposite of what we would normally want to do. Adding 2 to a number line normally moves us right. But when we see +2, it's actually going to be shifting the whole graph to the left. That's right. The graph, like everything you own in that box, is going to the left. And that is one plus of remembering that song. I don't know. I'm just throwing things to the wall, hoping they stick. Anyway, we're going to move it left 2. 1, 2, boom. Now it looks like this. So we've taken care of our horizontal shift. We move on to any horizontal or vertical stretching or shrinking. We can get that by multiplying y values by numbers or fractions, multiplying x values by numbers or fractions. But here, we don't have any stretches or shrinks. So I can just go ahead and knock that out too. Reflections across x and y axes. And here we have both. Here is a reflection, and there's a reflection. The one on the outside is the one that flips it over the x-axis. That one is our vertical flip. And then this one on the inside, that is our horizontal flip, our flip across the y-axis. So all of the points from over here move over here. Since we were 2 to the left, we would be 2 to the right. So our reflections, they're done. And then vertical shift, we don't have anything on the outside added or subtracted. So that one's done too. So our final graph would be the square root 2 to the right. And instead of going up and right, it ends up down and left. How did we get there? Well, we followed our order of transformations. First, our horizontal shift +2 took us 2 to the left, Then we flipped over the x and we flipped over the y. And those were all the transformations we had. We end up with this graph. Let's start with some notation. We've heard of f of x. We've heard of g of x. Introducing f plus g of x. So why have I written f plus g in parentheses? Well, if I didn't, it would just be the letter f plus g of x. We're indicating that we want f plus g, and that's why the whole f plus g has to be in parentheses, because the letter f plus a function is what it would be without. And why is it important that we know that this is f plus g? Well, f plus g of x just means f of x plus g of x. F minus g of x. That one just means f of x minus g of x. f times g of x. Guess what that means? I don't think you can do it. Oh, crap, you did it. F of x times g of x, sure. This notation is telling us what to do to the functions by doing it to the function names, and it's staying a function by telling us that this is the name of the function of the variable x. Again, this doesn't mean f plus g times x. Just like f of x doesn't mean f times x. It is a function named f that uses the variable x. This would be a function called f plus g. It is a function of x. What does it mean? Well, it's f plus g, f of x plus g of x. There's one more of these. I'm not going to write it down here. I'm going to give it its own space. You already know what it is. It's the one I didn't do. F over g of x. F over g. F divided by g. F of x divided by g of x. Now, when we say f of x divided by g of x, we are making a big assumption about g of x. I'm going to see if you can get there before I actually say it out loud, but I'm going to start hinting around it. G of x is on the bottom of a fraction. We're dividing by g. There's a certain thing we can't have on the bottom of fractions, and therefore it's a certain thing g of x can't equal. G of x, if we're expressing f over g, can't be 0 because we can't divide by 0. That makes this a restriction of this function. So let's say we had f of x equals 9x, g of x equals x plus 2. I'm going to keep them relatively simple right now. What would f plus g of x be? Well, we know that f plus g of x means f of x plus g of x. F of x is 9x plus g of x is x plus 2. So f plus g of x would be 10x plus 2. To get the addition function, we add the functions together. And adding functions is no different than adding polynomials or adding whatever they end up being. It's just a new notation that we're getting used to. We know how to do 9x plus x plus 2 already. F minus g of x. Here I want to warn you to be careful. F minus g of x would be f of x minus g of x. But just like any time we're doing a substitution right after subtraction, Subtracting g of x means subtracting the entire g of x. That x plus 2 needs to be in parentheses. F of x is 9x. So we have 9x minus 2. F minus g of x would be 8x minus 2. F times g of x. Let's do that next. Fg of x would be f of x times g of x would be 9x times x plus 2 would be 9x squared plus 18x. We're distributing. None of this is new. This is classes old. What is new? The notation. I'm going to keep a note down here that fg of x worked out to be 9x squared plus 18x. Let's say we wanted to find fg of 2. Well, one way to do this, fg of 2, just like fg of x is f of x times g of x, fg of 2 would be f of 2 times g of 2. What's f of 2? Plug 2 into f. 9 times 2 would be 18. What's g of 2? Plug 2 into g. 2 plus 2 would be 4. And then 18 times 4 would be the same as 9 times 8. So it would be 72. Fg of 2 equals 72. Well, guess what? If we have the function fg of x, we can just plug 2 right into that. Fg of 2 would be 9 times 2 squared plus 18 times 2. That would be 9 times 4 plus 36, which would be 36 plus 36, which is, guess what? 72. So everything's working exactly like it should here when we do algebra with functions. Now, 9x and x plus 2, various different ways. Those work together well. Let's say our functions were a little more complicated. Let's say we had f of x equals the square root of 25 minus x squared. And let's say that g of x is just the number 5, constant function. Well, what would f plus g of x be? Well, that would be f of x plus g of x. It would be the square root of 25 minus x squared plus 5. And that's it. We can't combine that at all. The 5's not under the square root. We can't just take the square root of 25 when it's the square root of this expression. So that's as far as we can take it. That's the final answer. Square root of 25 minus x squared plus 5. Let's do some more. I'm going to pick some different functions. We're going to say m of x is 4x. We're going to say n of x is the absolute value of x minus 3. And we're going to say p of x is 1 over x plus 1. So 3. First, let's find, let me decap a bunch of these. What kind of markers would I like? Decap, please. Oh, sorry. Okay. Let's find m minus, forget what I wrote, m minus n of 2. Well, what do we know? M minus n means m of the function, in this case, m of 2, or m of the function input, sorry, minus n of 2. Function m, that's 4 times our x, in this case 4 times 2, minus n is the absolute value of the thing minus 3. Here the thing is 2. That's not a 31, that's a 3 and end of our absolute value. Let's simplify. 4 times 2 is 8, minus the absolute value of 2 minus 3 would be the absolute value of -1. Absolute value of -1 is +1, so this is 8 minus +1. I've done something wrong. No, I haven't. This is correct. Next, let's do the same thing, m minus n, but instead of positive 2, let's go ahead and find m minus n of negative 2. So our next example, m minus n of negative 2. So that's m of negative 2 minus n of negative 2. M would be 4 times the thing. Thing's negative 2. Minus n of x minus 3 would be negative 2 minus 3. 4 times negative 2 is negative 8 minus the absolute value of negative 2 minus 3, absolute value of negative 5. The absolute value of negative 5 is positive 5, and negative 8 minus 5 is negative 13. Next up, let's do m times p of 1. Well, that's going to be m of 1 times p of 1. M of 1 would be 4 times 1 times p of 1 would be 1 over x plus 1, or x is 1. 4 times 1 is 4 times 1 over 1 plus 1 is 1 over 2. 4 times 1/2 is 2. So m p of 1, m times p of 1 is 2. For the one like this I'd like to do, I'm going to get rid of the number entirely. I'd like us to just find mp of x. Well, that's going to be m of x plus p of x. We don't have a different number to plug in, so it's just our basic definition. M of x times p of x. So that's 4x times, or sorry, I wrote plus there. This should just be times. Forgive me. Times m of x times p of x. 4x times 1 over x plus 1. Multiplying something by a fraction just multiplies it by the top. This is 4x over x plus 1. MP of x equals 4x over x plus 1, because that's 4x times this fraction. And by the way, MP of 1 would be 4 times 1 over 1 plus 1, which is 4 over 2, which is 2. Just like we got when we did it the long way. Next up, using these three functions, I want to do P over N of 3. P over N of 3. That would be P of 3 over N of 3. Well, what's P of 3? P of 3 would be 1 over 3 plus 1. What's N of 3? N of 3 would be the absolute value of 3 minus 3. So we could keep going and simplify the top, but we already got our answer. Top's 1/4. The bottom would be the absolute value, 3 minus 3. The absolute value of 0. So 1/4 divided by 0, that's undefined because we can't divide by 0. This meant the thing on the bottom was equal to 0. So remember, I said when we have the division one, we have to make sure the function on the bottom, in this case, n of x, isn't equal to 0. And when we specifically plug in 3, that's the value that makes n of x equal to 0. So it's the value that causes this to be undefined. I want to give 3 new functions. And g of x equals 2x. H of x equals x squared minus 4x. And k of x equals the square root of x minus 1. These are the functions we're going to use to talk about determining domain of a resulting function. Okay, let's do g minus h of x. And we're going to write the domain of it in interval notation when we're done. So we need g of x minus h of x. That's going to be 2x minus x squared minus 4x. And what am I missing? What do I need? I need those parentheses because I'm subtracting the whole thing. The colors really showed why we need the parentheses there. We are subtracting all the orange, not just the x squared. If we simplify this, we have 2x minus x squared plus 4x. So we just have minus x squared and then 2x plus 4x plus 6x. So this would be g minus h of x. Now we also need to write the domain in interval notation. And the rule is going to be that we take the intersection of the domains that we started with. What does that mean? It means the overlap. The domain of g of x would be all real numbers. There's no restrictions. There's nothing we can't plug in. And remember, we find the domain by figuring out what we can't have. The domain is everything we can have. So it's easy just to pick out the things we can't and say everything else, that's the domain. Here, there's nothing to pull out because nothing makes this undefined. So everything is in the domain. Same with h. This is also all real numbers. So the domain of both is all real numbers. And that means the intersection, the overlap of those two intervals would also be all real numbers, because there's nothing we can plug in that would make it undefined. And sure enough, if we look at this function, there's nothing that would make it undefined. Looking at the final function and determining its domain that way, we're going to see is not a good idea. Not a good idea, because it's going to give us some wrong answers sometimes. We have to take each of the starting domains into account. Let's do g times k now. So g k of x. That would be g of x times k of x. That would be 2x times the square root of x minus 1. Now, the domain of g, we already said that one's negative infinity to infinity. We've said the domain of h is also negative infinity to infinity. What about the domain of k? Well, the thing under a square root has to be greater than or equal to 0. Remember, we can't have negatives under the square root, and still be in the real numbers. If I add 1 to both sides, x greater than or equal to positive 1, and in interval notation, that would be square bracket at 1 to infinity. If you don't remember how to do interval notation, there are review videos available to you from past classes from the front of the book material. You're going to want to look at, I believe it was section 1.4. That's the one where we talk about union and intersection of sets. We talk about interval notation. So find that union and intersection of sets video if you need to refresh on how to do interval notation. That's not a part of this class. That's in the prereq. You're expected to know it. But my old videos, well, they're new videos, but the old material is available to you. So we would need the intersection of the domains for g and k. Where do they overlap? Well, since that's everything, The overlap is just going to be the same as the domain there. So the domain for this function, our final answer of 2x radical x minus 1 is this. And that's saying that we only get an answer. The function is only defined for these values of x, for x is in that interval. Anything else would be undefined. Okay. Next one we're going to look at. Let's do k over h of x. That's going to be k of x over h of x. Now, making a function like this, k of x over h of x, we like that because that's easy. These things can interact with each other because the k's in the square root realm. The h is not. So after we put k over h, guess what we can do? Absolutely nothing. That is the final answer. I'm writing again so you see it in purple, but same exact thing. Now for the domain. The intersection is still this. But there are also going to be values that make the bottom 0. And we have to find those values because we're not allowed to have the bottom equal to 0. So x squared minus 4x can't be equal to 0. How do we solve quadratics like this? We factor. Again, that is old material. X minus 4 times x is what gives us x squared times, x squared minus 4x. So that means x equals 0 or x equals 4. I'll even write that out. X minus 4 equals 0. So x equals 4. Specifically, these were not equal. So they are restrictions that we can't have. The 0 we don't have to worry about because we already have the intersection. We already have the domain narrowed down to being 1 to infinity, including 1. 0's not in there anyway, so we don't have to worry about it. This 0's not already in there. It's already excluded by not being a part of the intersection. However, x equals 4, that is in the intersection. So we need to take it out. This is going to be including 1 to 4, not including 4. Union with 4 to infinity. So it's like I took this interval and I removed the number 4 so that it's still from 1 to infinity, but you can see this end and this start is specifically excluding the 4 value. So that would be the domain. we're given P of X is X squared plus 5X. And as much as I love color coding, I'm going to do this one in blue, since it's the only marker that's not disappointing me right now. Q of X is the square root of 2 minus X. We want to find Q over P of X, which we know means Q of X over P of X. So we take our Q, it goes on top. We take our P, it goes on the bottom. X squared plus 5X is P. Square root of 2 minus X is Q. Q over P is literally putting Q over P. Square root is only on the top. We need to find the domain of this, though. So what can't we have? Well, the domains of each of these, P itself, X squared plus 5X, there's nothing we can't have there. So the domain for P is all real numbers. For Q, things under a radical have to be greater than or equal to 0. They can't be negative. So negative X would be greater than negative 2. Multiply or divide both sides by negative 1. Either way, that flips the inequality. X less than or equal to 2. So the domain for Q is negative infinity to positive 2. But there is something else we have to consider besides just the domain of each of these. The bottom of the fraction can't be equal to 0. X squared plus 5X cannot be 0. How do we solve that? We factor. X times X plus 5 can't be 0, which means X can't be 0. X plus 5 can't be 0, so X can't be negative 5. So we're going to take the intersection of these two where they overlap, and that's just going to be this here. All real numbers and the real numbers up to and including 2 overlap as the numbers up to including 2. But we also have to rule out X equals 0, and we also have to rule out X equals negative 5. So what does that give us? It gives us negative infinity to negative 5. Rule out negative 5. So union, there we go. Then we keep going, negative 5 up to, but not including 0 because we're taking out 0. And then we can go all the way up to 2 and include 2, but this will be the domain. Why is it important to figure that out? Because it's not enough to know this part. The question said, find the function and write the domain in interval notation.